Question 46. Can you explain the difference between encoders and decoders in transformer architectures? In transformer architectures, encoders process input sequences to produce meaningful internal representations capturing the context of the input data. Decoders, on the other hand, utilize these internal representations along with previously generated tokens to produce the final output sequence. For instance, in machine translation tasks, the encoder analyzes and understands the source language, while the decoder generates accurate translations into the target language, facilitating effective sequence-to-sequence tasks. Question 47. How do large language models, LLMs, differ fundamentally from traditional statistical language models? Answer. Large language models differ significantly from traditional statistical language models, such as n-gram models, in several fundamental ways. Architecture. LLMs leverage transformer-based architectures capable of capturing long-range dependencies and complex contextual relationships, unlike simpler, local context-focused statistical methods. Training approach. LLMs use unsupervised pre-training on vast datasets, enabling them to learn diverse patterns without explicitly labeled data. In contrast, traditional statistical models rely on simpler frequency-based analysis, often using supervised data. Scalability and performance. LLMs can generalize effectively across many tasks, though they require substantial computational resources. Statistical models are simpler and less resource-intensive, but limited in flexibility and contextual understanding. Question 48. What is a hyperparameter, and why is tuning hyperparameters critical in training large language models, LLMs? Answer. A hyperparameter is a preset configuration value that controls various aspects of model training, such as the learning rate, batch size, or model depth. Hyperparameters are not learned from data, but determined prior to training. Proper tuning is crucial because these parameters significantly influence model convergence, stability, and overall performance. For instance, setting a learning rate too high might cause instability, whereas too low could slow down training. Optimal tuning ensures the model achieves the best possible accuracy and efficiency. Question 49. What would you define a large language model? Answer. A large language model is an advanced AI model trained on massive textual datasets to understand, interpret, and generate human-like language. Typically characterized by billions of parameters, these models leverage extensive contextual understanding gained during pre-training to perform diverse linguistic tasks such as translation, summarization, question answering, and dialogue generation. Their versatility, broad applicability, and ability to generate coherent, contextually relevant responses distinguish LLMs as foundational tools in modern natural language processing. Question 50. What are the primary challenges faced when deploying large language models? Answer. Deploying LLMs presents several key challenges. Resource intensity. They require substantial computational resources, impacting infrastructure costs and scalability. Bias. Models may perpetuate biases present in training data, raising fairness and ethical concerns. Interpretability. Their complexity makes understanding and explaining their internal decision-making processes difficult. Privacy concerns. Handling sensitive data raises potential privacy and security issues requiring careful management. Effectively addressing these challenges ensures ethical, reliable, and scalable deployment of LLMs in real-world applications.